Welcome back. In today's video, we are going to be discussing chemical equations. Not just chemical reactions, but chemical equations. A chemical equation is a statement or sentence that describes a chemical reaction. It describes what's actually happening in a chemical reaction as the chemical reaction is taking place. So there are two varieties of chemical equations that you need to be familiar with. You have word equations, and we have skeleton equations. Word equations and skeleton equations. So as the name suggests, word equations and skeleton equations are a little bit different. So let's talk about these first. Word equations use chemical names and other descriptive words to describe the reaction. So you're going to have those IUPAC chemical names that are going to tell you what chemicals are involved, and then there's going to be some other words that tell you what they're doing. All right. So an example, hydrogen gas combines with oxygen gas to produce liquid water. So we have words telling us that we have hydrogen and oxygen are combining and they're producing water. And we're told that the hydrogen is a gas and the oxygen is a gas and the water is a liquid. So it has descriptive words. This is a word equation. It's basically just a sentence telling us what is going on in the chemical reaction. A skeleton equation uses chemical formulas instead of their names and other symbols to describe the reaction. So it uses the formulas and symbols instead of words to describe the reaction. So the same reaction that we just had, 2H2G plus O2G arrow 2H2OL. The way I would read this is H2 plus O2 yields 2H2O. So those lowercase letters in parentheses, the G and the L, after them tell the state of matter. So S is solid, L of course is liquid, G is gas, AQ is aqueous, which is a word that means dissolved in water. So if I have a solid that's dissolved in water, we would call it an aqueous situation. You're not always going to have those because you don't always know the state of matter in the reaction when you're told or given that. So if you know the state of matter, then we add that in our skeleton equation. If we don't know the state of matter, then we just leave that off. But that's what those little letters in parentheses mean. S, L, G, or AQ are for solid, liquid, gas, or aqueous. The arrow is read as either yields or produces. So hydrogen plus oxygen yields, or hydrogen plus oxygen produces water. Now, different substances are separated by plus signs. So if hydrogen and oxygen are combined together, notice on the right side we have H2O. There's not a plus sign between them, which means they're all one compound, one substance combined together. They are their own thing. Whereas on the left side, in the reactant side, we have H plus O. So we have a separation of substances, and we separate them using plus signs. Now, the numbers in front are called coefficients. So that 2 in front of the H2 and the 2 in front of the H2O are called coefficients. We are going to discuss coefficients a little bit more in depth later and why they're there and what they mean in a later video. Just know that that's what they're called, is the coefficients. Just like in math, when you have the coefficient of x, so that 2x or 3x, it's a coefficient, it's a number in front. That's what those numbers are. So skeleton equations are always written with the reactants on the left side of the arrow and the products on the right side of the arrow. So we're always going to have it go from reactants to products. Reactant, because we read from left to right in English, and these rules were developed using the European language style, where pretty much all European languages read from left to right, so we're going to read from left to right. And reactants come before the products because they're the things that are producing. So the reactants will always be on the left side of the arrow. The products are always going to be on the right side of the arrow. So in this particular example that we've been using, hydrogen gas and oxygen gas are the reactants. They're on the left side of the arrow. And there is only one product. It is on the right side of the arrow. So we have our reactants, we have our products, and hydrogen and oxygen are the reactants, water is the product, left and right. So make sure you remember, because I will ask you many times, what is the reactant, what are the products. So the reactants are on the left, the products are on the right. Don't forget diatomic elements. I chose this particular reaction because it uses diatomic elements in the reaction. Remember, we talked diatomic elements are those 7 special elements that are so reactive that they do not exist by themselves in a single atom form in nature. So when they are in their elemental form, they are always going to be combined in a molecule of 2 of the same element. So don't forget them. Those 7 diatomic elements are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, or as I told you previously, Brinkelhoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Anytime these exist as an element, when you're writing your skeleton equation, they have to have the 2 because they are always going to be diatomic. Now, there are also 2 elements that you need to remember that are polyatomic elements that are going to exist in a polyatomic nature, more than 2, more than 1, poly, many. And those are sulfur and phosphorus. Sulfur is always going to get an 8 when it's by itself. When it's elemental sulfur, we do S8, and elemental phosphorus, P4. So you need to remember those. So you've got your 7 diatomics and your 2 polyatomics. All right? And they are always going to get a subscript when you are writing the skeleton equation, but only when they are in their elemental form. When they're combined in a compound, then that goes away and you write them down just the way you would whenever you write the formula correctly for the chemical name. That's why we spent the time talking about the nomenclature. So follow the IUPAC rules. This only applies, these diatomic and polyatomic elements, these subscripts only apply when you're dealing with the element, not compounds that contain them. So we're going to do some examples of writing skeleton equations from word equations. So we're going to give you some word equations, and we're going to go through the process of writing the skeleton equation from that. This is a very useful skill, something that you're going to need to be able to do, because it's a whole lot easier to type the words than it is to type the skeleton equation. So oftentimes you're going to see the equations written out and typed out in word form, but in order to do a lot of the chemistry that we do with them, we need the skeleton equation, because the skeleton equation is where we get the numbers and stuff that we need to do the math with when we're doing chemistry. So we're going to do some examples of writing skeleton equations from the word equations, and you'll see how this goes. So for our first example, we're going to do magnesium metal reacts with oxygen gas to produce a white powder called magnesium oxide. So we're going to start off by writing out our chemical names. We have magnesium metal. Well, magnesium is Mg, and it's just the element magnesium, but we know that it is metal, which means it is a solid. So I'm going to go ahead and put the state of matter there. So, and it's going to react with, so that means I'm going to use a plus sign because I have something else. Magnesium metal reacts with oxygen to produce a white powder called magnesium oxide. So oxygen is one of our 7 Brinkelhoff elements, so it has to have the 2, and it says oxygen gas, so I'm going to include my state of matter in parentheses. So magnesium metal reacts with oxygen gas to produce, there's my arrow, magnesium oxide, a white powder. So magnesium oxide is MgO, and that white powder tells me that it is a solid. So I have my magnesium oxide, magnesium plus oxygen react to produce magnesium oxide. This is our skeleton equation for that word equation. All right, so the next reaction that we're going to do says when heated, ammonium dichromate decomposes to produce chromium 3 oxide and nitrogen gas and water vapor. So we have first ammonium dichromate, and ammonium dichromate is NH4 2 Cr2O7. I'm not going to go through the whole thing of how to get that name, so just remember you follow the IUPAC rules to get the nomenclature, get the correct formula for your ammonium dichromate. And now, it's when heated, it's going to decompose, which means there's only one reactant. Notice it doesn't say it's combined with or added with or reacts with. It says it decomposes, which means we're going to get just a single reactant, and so it decomposes. Now the when heated will tell me that I'm going to put something here. We'll talk about that a little bit later. It's not really that important right now, but I'm going to put a little triangle there that signifies that this happens when you add heat, and it's going to produce chromium 3 oxide, which is a powder, so there's our solid, and nitrogen gas. Nitrogen's one of those Brinkelhoff elements, and water vapor. Now I'm running out of room on the screen here, so I'm going to write this down here. So plus water vapor. Water is H2O, and vapor tells us that it is a gas. So I have my ammonium dichromate produces chromium 3 oxide, nitrogen gas, and water vapor. So this is the skeleton equation once again. Okay, so now our next example, we have chromium metal when added to water reacts to produce a precipitate of chromium 3 oxide and hydrogen gas. So we have chromium metal, which is simply going to be the element chromium, but it's a metal, so we're going to have the solid there, chromium metal, when added to water. So I'm going to add it to water. Now, water, if I just say water, if the thing just says water, we can always assume that that's liquid water, even if it doesn't tell us liquid. We're typically going to say water vapor if we mean a gas, or sometimes steam, or ice would be solid water. So if it just says water, you're always going to just assume it's the liquid water. So chromium metal, when added to water, reacts to produce, so there's our arrow, reacts to produce a precipitate of chromium 3 oxide. So I have my chromium 3 oxide, and it's a precipitate, which by definition means it's a solid, and hydrogen gas. So again, hydrogen is one of those Brinkelhoff elements, so it has to have the 2 whenever we have that. Notice I did not put the 2 with chromium because chromium is not one of those diatomic elements. Hydrogen is one of those diatomic elements, so it has to have the 2 when it's as an element. So no subscript because it's not one of those 7 diatomic or the 2 polyatomic, so it does not get a subscript. This one is one of those 7, so it does get a subscript. So you don't just give it a subscript anytime you want. You have to pay attention. If it's not one of those 9 elements that we talked about before, you just write the element symbol when it's an element. All right, so this is the skeleton equation for that one. All right, so our next example is aluminum acetate powder reacts with sulfuric acid to produce aqueous aluminum sulfate and acetic acid. Okay, so aluminum acetate powder. Well, aluminum acetate is AlC2H3O2 3. So aluminum acetate powder tells us it's a solid. Reacts with sulfuric acid. Sulfuric acid is H2SO4. To produce, so there's our arrow, aqueous aluminum acetate, aqueous aluminum sulfate, let me say it right. So I have aluminum sulfate, and it's aqueous, so I have the AQ, and acetic acid, which is, I'm going to write it down here because I'm running out of room, HC2H3O2. All right, so there is our skeleton equation from that word equation. Aluminum acetate, solid, reacts with sulfuric acid to produce an aqueous aluminum sulfate and sulfuric acid. So that's that example. All right, in this last example, I'm going to give you a chemical name that's not one of the IUPAC names. So we have octane, which is, and I gave you the formula there, C8H18. That is actually an organic compound, so this is not this is an IUPAC nomenclature. It's just not the IUPAC nomenclature that we learned in the previous videos. So octane burns in the presence of oxygen. So in the presence of oxygen, that would be O2, and oxygen is a gas, to produce carbon dioxide. So it produces carbon dioxide, gas, and water vapor. So H2O, and it is a vapor, so that would be a gas. So I have octane reacts with oxygen to produce carbon dioxide and water. This is our skeleton equation for that. Hopefully you see now how to go from a word equation to a skeleton equation, and it's not super complicated to do so as long as you can do those IUPAC nomenclature and you can get the correct formula. Then going from word equation to skeleton equation is fairly simple, and you need to be able to do this because moving forward in following lessons, you're going to see that we're going to use the skeleton equation a lot. Thanks for watching. Have a day.